Okay, hi, I'm Murray. Thanks for coming to my talk. As my intro mentioned, one of the things I do is co-organize the London Ruby user group, LRUG for short. And if you really stress the L, you can pronounce it as LRUG, hence the logo. We meet monthly on the second Monday of the month, every month. If you're coming to London, you should arrange your holiday to coincide with one of our meetings so that you can come chat to us about Ruby and learn that the ocean that divides us can be easily bridged by a love of open classes, blocks, and duck typing. A thing I have to do as part of organizing that meetup is randomize the names of people. Very often, I've needed to choose the winners of a raffle or a giveaway. Once, we ran a battleships tournament as a practical exercise, and I had to pair up the participants to create the playoffs. For a particularly packed meeting, rather than curating a perfect agenda as Sarah and Jenny have done for the weird Ruby track at this conference, I'll just randomize the order of the talks. It happens more than you might think, so I like to have a system. Now, the obvious way to do this is to write everyone's name on a bit of paper and put the bits of paper in a hat and draw the names one by one to select a winner and generate the order. And that's fine, but it's not very Ruby-y, and this is RubyConf, not paper and hats conf. So how can we do that with Ruby? Well, I'm delighted to tell you that Ruby is the perfect tool for the job. Array shuffle will return your array in a new randomized order, perfect for tournaments and running orders. An array sample will pick a random element from the array, which is perfect for prize winners. So everything we need is right here. They talk about Python as being batteries included, but I think Ruby is doing really great here. In practice, if I was Sarah or Jenny, I might have done something like this. We put the list of names into our hat, an array, and then we pick the names from it, calling shuffle or sample depending on our need. And then we announce that result by calling put. If we run the snippet, we'll get a running order for the weird Ruby track in an instant, and we can go and catch up on some prestige TV with the time we've saved. And the code is so elegant. It's beautiful. So that was names from a hat. We got right into it, and we found out that Ruby does exactly what we want. But I have 28 more minutes to fill. Luckily, an alternative title for this talk is Over-Engineering for Fun, Not Profit. Now, I'm an engineering manager at a company called Clio. We're a fintech building an AI assistant that turns the complexity of personal finances into a conversation, the same kind you'd have with a friend. And it supports people throughout their financial lives. At work, what's important is shipping the smallest possible thing that lets us deliver value to our users, or the business, ideally both. And we do this by building on top of existing features, gems, third-party service providers, so on. This lets us move quickly to build the simplest thing that will meet the requirements, and we're not afraid to shrink those requirements to help us get something out sooner so we can learn. Why build an all-singing, all-dancing product feature when a landing page test might tell us just as much and sooner? What I'm saying is over-engineering is bad at work. But this is weird Ruby, not best practices thought leader Ruby. So let's quiet that EM at a startup voice down a bit. I'm here to sing the praises of over-engineering for fun. We're going to do that by exploring some of the ways I've personally over-engineered calling array sample or array shuffle while wearing my LRUG organizer hat. Along the way, because we should embrace all parts of ourselves, that EM at a startup voice might pop up with a few occasional thoughts on recreational over-engineering being good, actually. So the first thing we're going to look at is that I wanted to learn about a new feature of Ruby. As part of the Lightning Talks evening at LRUG, I decided to give a talk about the, at the time, new feature in Ruby called fibers. These days you might want to talk about ractors. I didn't know anything about them, so I had to go and research how they worked and what they were, so that I could give the talk about them. I learn a lot by researching and reading about a topic, but I learn even more if I hold the technology in my hands and make something with it. So I had a problem I know how to solve, randomizing a list of speakers, and a technology I wanted to explore, Ruby fibers. This is the best combination for learning, I reckon. And it was the final thought of my talk, Reinterpreting Data, last year. So I won't belabor the point. I'll just suggest that you go find that talk and bask in, actually, don't watch my talk from last year, Instead, go to this URL and watch Pursuing Pointlessness by Chris Howlett from this year's Brighton Ruby conference. It's a 5-minute lightning talk that covers the exact same themes of exploring fun things as my talk, but it takes like 10% of the runtime. It's so good, I'm not even mad about it. So, back to fibers. I'm not here to explain fibers, at least not in detail, but the extremely high-level version is that they are a concurrency model that allows for explicit control flow between different running parts of your code. You can imagine that this line represents all the code in your Ruby program, and this Ruby represents CPU time in the program. In a single-threaded program, your CPU is doing one thing at a time, and it just runs through the program until it gets to the end. With multiple threads, we get the illusion of multiple things happening at once, as represented by 2 lines of code. But it achieves this by giving each thread a tiny bit of CPU time before moving on. Random interrupts tell each thread, stop, it's someone else's turn now, and you're not in control of when that happens. So you have to code really defensively around it to avoid deadlocks and access to shared objects. In fibers, there's still only one thing running at any one time, but you are in control as you explicitly tell the CPU when to run code in one fiber and when it should stop. And that's what these fiber yield and fiber resume calls are doing. We're passing control back and forth between 2 fibers programmatically. Anyway, this is how I over-engineered the problem of randomizing speakers using fibers. We can see the fiber yield and fiber resume calls here. I've got multiples of both, so I'm passing control around a fair bit. Here, we give the random choice fiber a list of names for it to work with, and entirely avoid issues of shared memory access because we're in control of when CPU time is passed around. Safe between the fiber yield calls in the loop, the fiber can do whatever it wants to that array, safe in the knowledge that those manipulations won't get interrupted by someone else. What it does is randomly pick a name and delete it from the list before passing that name out in the fiber yield call. The keywords that you can use to Google later for this are coroutines or cooperative multitasking, or like go to the session being run by Jamis and Adviti later about flattening recursion with fibers. Now, obviously, you don't need fibers to do this. I have over-engineered this for sure. I mean, I'm even using the wrong array method. I should be using shuffle, but I'm using sample to get individual elements. Not gonna lie though, I did enjoy the frisson of danger that I got from writing an infinite loop. That's not something you get to do often in production code, is it? That's one, I think, of the fun things about fibers. You can kinda almost throw away your ideas about termination and loops. Anyway, I wouldn't say I've used fibers in production. I know that deep in the stack of my Rails apps, there are fibers being used somewhere, but I didn't write that code. Having explored fibers a bit, though, I do have some residual knowledge lurking in my memory, ready to leap out and be useful at some point. For example, if I have to spelunk deep into the libraries we use and encounter fiber code, or if I have to debate the merits of the Puma app server, which is thread-based, versus the Falcon app server, which is fiber-based. So my plea to you, go explore some technology you're not using and have no real need to use yet. Use it to solve some problem it's wildly inappropriate for. You'll get exposure to it and be that more familiar when you encounter a problem it is appropriate for. You don't want shipping to production a new mission-critical feature of your app to be the first time you've ever used that new technology. The next way I over-engineered randomizing names was to build a UI on top of the process. I wanted a more visual element to the problem because we would randomize the speakers on the night. So I wanted there to be something more interesting to view than like strings in a terminal. And I wanted to do it end-to-end in Ruby. At the time, the tool for doing that was to use Shoes, which was one of Y Lucky Stiff's projects. It's a version of Ruby that can be used to build desktop applications. The UI elements are very similar to what you're used to with HTML, and positioning is also very similar to what you do with CSS. So it's very familiar if you're doing web stuff for the day job. So this is what I came up with, and before I click play on the video, there is some flickering, so if that might hurt you, like avert your eyes and I'll tell you when you can look back. So this app shows a list of potential speaker names. When you press the button, it cycles through the names to highlight the one that might be chosen. When you press the button again, it picks one and shows it big. Then you repeat this process until all the names have been chosen, and your final button press shows a list of all the names in the order you chose them. Quite the step up from strings on the terminal. Success! Now, obviously, you could do this kind of UI in the web. The difference is that we have to think in two languages to do it. Ruby for the backend on the server and JavaScript on the client. With Shoes, it's all Ruby, and that's what's fun about this version for me. The whole app code isn't huge, but more than I can squeeze on a single slide, so I'll show you some of the interesting parts. The flickering is done now, if you were bothered by it. This is the bare bones of the app. Like Fibers, I'm not going to go into lots of detail on how Shoes works, but you can probably see that it's a DSL for writing GUIs. Lots of do end blocks and new UI phrases. You start everything with a shoes.app method, and this unlocks the Shoes DSL for use in the block. And it also renders the Shoes UI window onto your desktop. There's no initialize method, so if you need some internal state, you just set that up in the block. Here I'm using ask_open_file to get the user to give us a file name that we read the list of names from, and then I'm setting some other variables for use later. Next, we have the background method to set the background color of the app. All the fun named colors from HTML are there, so you don't need to break out RGB triples if you don't want to. Now we get into something more shoesy. Stack defines a UI element container that stacks the elements you put into it, vertically, one on top of the other, which is in contrast to the other major building block of Shoes, which is the flow element, which flows the elements horizontally. Now yes, these are very similar to the block level and inline level elements you get in HTML. They are simple, but give you lots of scope for flexibility in layout. The methods in the stack there are some of my other implementation details that actually render the button and the list of names that you saw in the video. Finally, we have the animate method and block. I'm asking it to run this block of code 24 times a second. Just like a film, seemed like a good choice. If our state supports it, we'll pick a winner to display. These are the basic building blocks. There's lots more to explore, but this is enough for now, I think. It's the Ruby you know and love, driving a simple but powerful UI kit, and it's well worth exploring. If you want to find out more later, just search for Shoes RB. You can't really search for shoes or Ruby shoes because you are just going to get actual shoe on your foot content. I do want to show you how to add interactivity though, so here's the code for the button. We provide the button text and some styling attributes, and a block for the behavior that will be run when you press it. And this is where I think I've gone off the rails, or should I say shoes? Anyway, triggering the button should just toggle some state that other code reacts to, highlighted here where I'm setting the randomising flag. But I've also mixed in updating some internal data, some UI code, and what's most frustrating is that the luckiest variable, where has that come from? Well, it's part of the pick a winner method called in the animate loop. In this method, we have our old friend array sample to pick a name from the list of volunteers, and that stores it in the luckiest variable. But it also updates the names to style them differently if they're the current chosen one or not. All the things I want to happen are happening, but it's not really done in the way you'd want it to for sustainable future development. And that's fine. This is a one-off program for a meetup, and I doubt anyone had seen this code until I showed it to you just now. There's a lot of code to wrap around that little array sample call, so definitely over-engineered. But why I think this was useful is that it exposed me to GUI programming and helped me to understand writing code in a different paradigm. Mixing state and behavior is the problem with the code I showed you. And while that's not unique to UI code, I do think it's a lot easier a mistake to make with UI code. Getting into it in Ruby made it really easy to make those mistakes. And I think in part because most of the Ruby code I write is fairly sequential. We might dress it up in patterns like active record or active job, and even use callbacks and pub/sub. But the fundamental pattern is a web request comes in with some params. We react in the moment to run some action and return a result. Maybe it kicks off some background processing out of band, but there's still a fairly straight line. Crucially, you don't need to worry about maintaining and updating state on long-lived objects because the web request or background job finishes quickly. With GUI programming, things are explicitly more event-driven, real-time, and long-lived. So to avoid getting into a big ball of mud, you need to think about separating behavior and state better. Front-end patterns like MVC, the original UI one, not the web one popularized by Rails, or reactive programming as popularized by React, do this really well. And if you want to understand what your front-end colleagues are up to, it's really useful to have tried your hand at it in Ruby. Get into a mess, like I have, and you will really understand why you might want to introduce patterns and structure. The next way I over-engineered the problem was another shoes application, but this time I wanted some more pizzazz on the screen. This time I needed to pick the winners for a bunch of prize draws we were doing for some books, so I wanted to drum up some anticipation of the draw, which we'd be doing live on the night of the meeting. In the one we just saw, the flickering names brought an element of tension. Ooh, it's highlighted my name, will it be me? But this time, I really wanted to be true to the original idea, drawing names from a hat. There's some mild flickering in this video too. So here's a simple scene in which I've drawn a classic magic top hat. And at the top, we have rendered the name of the book we're giving away as a prize. When you press the button, all the names from our list get animated and they go into the hat. Once they're all in the hat, it starts fizzing with magic energy. And when you get a new button with magic words on it, pressing that releases some magic energy by picking a name and replacing the book name with the winner's name. You can continue pressing the button until all the names have been chosen. I wrote it this way because we were doing the draw in person on the night. And if the person wasn't in the room, we just did it again. I had carried a load of books to the meeting, and I was not going to carry a load of books home from the meeting. It's still a shoes app, but I've leaned less into text and buttons and more into art and animation. So there's some neat things to show a case there about how we do that. The video is done for now, if you were avoiding your eyes. So first, here's the code for drawing the hat. Mostly these methods are picking a color, then drawing a simple shape, and then we lather, rinse, repeat in order to build up the overall hat image. The last call is to a handy star method, so you don't need to draw a bunch of triangles to approximate a star yourself. There was no hat method for the whole thing, though, missing a trick, I reckon. And there's not much to say here other than to point out that, like all of your designer colleagues, I had to painstakingly handcraft all of these left, top, width, and height attributes to position and size the hat in a way that looked good and fitted on the screen. If you've done any programming with processing or notebox or HTML canvas or even SVG, this might be familiar to you. So you can learn about this style of programming by searching for those things. It really is quite fun, and I'd encourage you to explore how to create interactive art using these techniques. The next bit I want to highlight is the animation. We saw some animation in the last example, so you remember we have an animate method that will call the given block each frame. I've learned from the last example, so the animate block here calls a method instead of having a big inline mess. Of course, the method is a bit of a mess, but I have hidden some of it so we can just look at how to make the magic star jitter about. If we don't have a winner, we need to do some magic to pick one. If we do have a winner, we need to stop doing magic and show it. Doing magic is a case of randomly moving the star within a painstakingly crafted bounding box. Stopping doing magic is a case of moving it back to the painstakingly crafted midpoint. What's interesting here is that for this animation, I only needed to think about what needs to happen during a single frame. Shoes animate method just repeatedly calls that, and the animation effect is created. The other bit of animation is dropping the names into the hat. It follows similar principles. The animate block calls main loop. Again, I've removed the code for other states. Relevant to us is that if we don't have a current name, we pick one and draw it on the scene. If we do have a current name, we then move it towards the hat. And if the result of that is that the name is in the hat, we clear out the current name. Next frame, we'll ask the same questions and either draw a new name to move into the hat or move the existing one closer to the hat. So how do we move things into the hat? Well, we work out how much we need to move the hat each frame in X, Y, and size. Then we ask, if we did move it, would it be in the hole at the top of the hat? If so, we put the name into the hat. and then return true to say, this name is in the hat. If not, we resize and move the element and return false to say, this name is not in the hat. The calculations for movement are interesting because we can change that one number to scale, to speed up or slow down the animation. Right now it's set to 24, which means roughly it should take a second to move each name into the hat based on the frame rate. If I change that to 48, it'll take 2 seconds. If I change it to 12, it'll take half a second. These calculations are sort of annoying and fiddly. Ask me later how many times I mixed up X, Y, top, and left. But you do just need to run it and eyeball it to see if it looks nice or not, which can be frustrating, but it is a real joy when you get something that looks good and animates smoothly. Again, I only had to focus on what I needed to do for a single frame. And yes, it's much more complex than making the star jitter about, but not by much. And it's endlessly tweakable and just fun to watch. The thing to take away from this, other than honestly just how much fun it is working on animation, is about how to break a problem down. With animation, because the block is called 24 times a second, I don't need to think too much about how to animate things completely, just about what it should do on each frame. Break the problem down into tiny slices, and you can achieve pretty neat results. This is fairly standard programming advice at the macro scale. Agile? Anyone? So it's nice to have it apply at the micro scale too. A good practical reminder of simple things adding up to complex results. So I liked the spectacle of the hat, but I felt that up to now everything was just a fancy version of the initial array implementation. Put a list of names in and call array sample or array shuffle to get a list of names out. I really wanted to make something truly interactive and where it felt like I was more a part of the randomization process. At best, in the previous versions, I was controlling a timing element of when to call array sample to get a random name out. The hat, with its main loop and button pressing state changes, reminded me of what little I knew about game programming. You create a world, you take some input, you update the state of the world, you render it, and then you loop. So I created a game called Rogue and the Speakers of Lightning. Let's watch it in action while I talk. I didn't think I could whip up a decent game in Shoes or anything else remotely graphically complex, but I did think I could do something in the terminal. Ruby is great at string manipulation, and with a big enough terminal window, you get plenty of screen real estate to render a world in. There's a terminal game called Rogue, where you play as a little @ symbol, traversing a dungeon as delimited by hyphens, pipes, underscores, etc. to make the walls. You find other characters as monsters to fight or treasure to collect. And randomness comes in that the whole dungeon is randomly generated each time you play, as is the positioning of the monsters and the treasure. Finally, the player themselves wanders the dungeon on their own desire, choosing which monsters to fight and in which order. This sounded like the perfect combination of computer and human randomization. I didn't know how to do it, but it's just string manipulation, and emboldened by my success with conquering animation with the hat version, I figured, how hard can it be? Well, let's see. We'll use that perfect measure, lines of code. V1, an array, 8 lines of code, and that includes the 6 lines of code needed for the names of the speakers. Fibers, 27 lines of code, which also includes the lines for the names of the speakers. Version 3, a simple grid of text with some mild animation, 119 lines. Version 4, an animated hat with multiple states of animation, 244 lines. Version 5, a fully fledged terminal game, 1,259 lines of code. So obviously I can't show you all of this, but there are 2 things I do want to talk about. The first thing I want to show is how we render the graphics for the game. As I said, it's a terminal game, so we're talking puts and strings. But don't worry, I have over-engineered that. First up, to draw the world, I have a tileset object, which has a render bang method. Now, this doesn't cause mutation or potentially raise exceptions. It's just exciting, so I gave it a bang method name. Sorry, RubyConf. The tile set contains an X by Y grid of tile objects, where each tile represents a single spot in the world, and another part of the system tells each tile what they contain: floor, wall, corridor, occasionally a wizard, or Elrogue itself as it wanders the dungeon. Rendering is just joining the array and asking each tile in the row to 2s itself, and then adding a new line between each row. Simple. 2sing the tile is also simple. If Elrogue is here, render the character for that. If a wizard is here, render the character for that. Otherwise, render the content, which is, the character for floor, wall, empty space, whatever the tile was told previously. Elrogue moves around, so we're constantly having to tell the tiles where it is. We do that in a method on tileset that tells all the tiles that Elrogue is not here, and then tells the one that represents Elrogue's current XY coordinates that Elrogue is here. It's not very efficient, but Ruby is fast enough to process all of this in between key presses for a terminal game. So far, so simple. What I realized is that with this in place, it was fairly trivial to add the circular reveal the map as you walk effect with a different tileset and implementation. In my foggy tileset, render bang doesn't change. We still want to just ask each tile to 2s itself. In my foggy tile, 2s relies on the tile knowing if it's visible or not. If it is, call super for the original implementation. But if it isn't visible, we render the empty tile. How do we know if it's visible? Well, we change the draw Elrogue method on the tileset to act as before. Tell the tile that represents Elrogue's XY coordinates that Elrogue is here, but also tell the tiles surrounding Elrogue that they are visible. Finding the surrounding tiles is iterating over every tile and using some Pythagoras. You will have learned this in high school, probably. The first time I've ever used it in production. On their coordinates to find those that are within the radius of the circle created by the strength of Elrogue's eyes. Not very efficient to do every tile every time, but Ruby's fast enough. The next thing I want to talk about is how we generate the dungeons. The code is fairly complex and spread across multiple files, but luckily I could easily tweak the engine to render the world and each step in the dungeon generation process to illustrate it, because of how excellent my design was for rendering via tilesets. So we take our world, here delimited in green, the full screen size of our terminal window minus a single row for instructions. Then we randomly split it. Random choice of horizontal versus vertical, and random choice of position, favoring the middle over the edges. This gives us 2 child worlds inside the original world. We then keep doing this with each nested world we've created until we have at least our desired number of leaf worlds. There's also a random chance that if we ask a world to split, it won't. Then we ask each world to place a room somewhere in the space, randomizing position and width and height. And then we link the rooms by drawing corridors to connect them walking up from the leaf nodes to their siblings and then their parents. And that is one way to randomly generate a dungeon. Did I know how to do this? Absolutely not. Did I invent this? Again, absolutely not. There are great resources out there for learning these techniques. There's a whole wiki dedicated to rogue building. I just picked the first technique I could get my head around, the one with the pictures to make it simple. And when I first built it and got it working, I spent ages just running it over and over and watching it to see what it would do. It was so much fun, I could spend forever doing that. There are so many more techniques for creating dungeons, and even different types of dungeons. I've chosen a rooms and corridors dungeon using a random subdivision model. You could use a uniform grid, or a random walk-in-place algorithm. You could create more cave-like dungeons that you hollow out of the terminal window using cellular automata or maze generation algorithms. Or you can combine different techniques. What I learned is that just like there are 1 million blog posts on how to structure your Rails business logic, there are 1 million articles out there giving you advice on game programming techniques. Our community isn't unique in how much it shares. As another little aside, turns out, although there's plenty of non-Ruby terminal roguelike content out there, I'm not the only person to fiddle around with Ruby for this sort of thing. A couple of months ago, Dmitry Sepilev published this lovely blog post talking you through the steps to build your own Ruby-based dungeon crawler. It has monsters and is way more game-like. You should definitely read this if you're thinking of doing it yourself. So, the other versions I shared were pretty much single-file scripts, just enough Ruby to get the idea out of my head and into an RB file. This game, I just couldn't do it in one script. I had to think about the problem and properly model all the pieces. the domain objects like worlds and rooms and creatures, and the infrastructure objects like tiles and tile sets and game engines. I had to think about patterns for how things would interact. I got to use the visitor design pattern. It's a small enough problem to keep in my head, but it's a big enough problem not to just YOLO it. It's a good exercise to work on something of reasonable scope and to get to apply this kind of thinking, so I could understand how to apply these ideas in a more professional setting. Shipping a new feature to production shouldn't be when you decide to experiment with a radical new way of modeling your business logic. So, let's recap all the ways that over-engineering can be good, actually. Or let's not. Just go and have fun. Pick up something and really push it. Learn something new, or don't. Make toys. Thanks for listening. Bye.